Voice okay? Clear? Thank you for the wishes. Voice clear? If clear, I will start. Okay. See, now make a note. What you have taken yesterday, we have considered systematically by considering each force, located line of action, then you found the net force with the couple. That is actually called systematic approach. Now, this also is not unsystematic, not that way, but it will involve time. When you usually practically, when you design retaining wall, remember, alternative approach, little gone, approach, note, usually used in case of stability analysis for retaining walls. Only changes there, some earth will come, that you can account there. So, this alternative approach, very systematically and easily you get the answer. You don't have to struggle, where is this load, and actually not that way. How to transfer the moment, then that's all not required. Direct step by step will come. See, consider 1 meter length of the dam. If retaining wall, you write, consider 1 meter length of retaining wall. See, goes this way. Now one change. If it is retaining wall, there will be a base slab here. Okay, that you account there. Then one extra weight will come. RCC I had done that one. But steps are same. Note, you know weight equal to volume into weight density. Volume equal to area into length. When you take 1 meter length this way, volume equal to area into length. So whatever area you are seeing here into length, length is 1 meter. So weight is directly equal to area in meter square, length is 1 meter into kn per meter cube. Answer will come in kilonewton, but for 1 meter length. Okay. Now, also note, if lateral pressure is acting, here due to water, there due to soil, in that case, pressure diagram is like this. Maximum pressure here. Weight density of water is taken 9.81. 9.81. Where I am? 9.81 kilonewton per meter cube. Okay. Therefore, pressure at any point equal to density of water into height. So here 0, height from top. Here, pressure is what? This maximum pressure is weight density of water. That is 9.81 into height is, for us it is some 7, I forgot. 7.5, I forgot completely. Is the height 7.5? That also I forgot now. I will remember now. Is the height 7.5 or 6 meter? What was the height? I think 7.5, remember. First I told 6 point something. Later I remember it. 7.5 I think, most probably. No answer, see. Is the height 7.5? You are not answering. 7.5. So, 9.81 kilonewton per meter cube into 7.5 there will give kilonewton per meter square. Pressure is always what? Per unit area. Unit area is this way 1 meter and this way 1 meter. Then resultant lateral force equal to basic average pressure into contact area. Average pressure 0 plus maximum pressure divided by 2 into contact area is height into 1. So therefore directly, see now, maximum pressure by 2 height into 1, or it is maximum pressure by 2 into height into 1, or half into height into maximum pressure is nothing but area of pressure diagram. So whenever you take 1 meter length, then or unit length, the resultant load will be always area pressure diagram. If it is soil, you have to multiply for this one into 1 minus sin phi by 1 plus sin phi. That is what? Coefficient of active earth pressure. That is soil mechanics. So there also same thing. This pressure will be equal to density into height into usually 1/3 it comes. Okay, then resultant lateral load will act at 1/3 height from here. Why? Through CG. Okay, now that is like this. I will call WL, W lateral. See, WL means, I written here, resultant load due to water pressure, WL. In retaining wall, you call it P, but here no, P means axial load later. So, symbol you change. Now, further procedure, I will dictate in the class, you write it. Further procedure, as I solve, I will dictate, you write it. Okay, start. Now start. Step. Consider our dam once again. See, these are all a basic concept. I will not explain again this one. Already told several times now. So now, start. I will not use any red color like that now. See. So now, alternate solution for previous example. Start statement. Right. Consider 1 meter length of dam here. Dam. Write the cross section. Consider cross section. That's all. Length is 1 meter. You can see like this. See. This way you can see it. This is the cross section. Now little bigger I will make it. See. Little big sketch. This way it will come rectangle and triangle. Divide into parts. Now this width is, I remember, 2.5 meter. Total is 4.3 meter. So this is 1.8 meter out of scale. Okay, done. 1.8 meter. Then, see, somewhere here there will be lateral pressure. That pressure will act this way. Okay, now, this point I will take A, this point I will take B. This AB is yes. Actually, this AB later, this is not that AB. Time being AB. Okay, AB line. This is, length is 4.3 meters. See, one weight acts here, right? Dam you section, trapezoidal, divide into rectangle and triangle. Take this load as W1. Take this load as W2. Resultant lateral force, take WL. The total height is 7.5 meter. No H, nothing now. 7.5. So this will be acting at 1/3 of 7.5 equal to 2.5 meter. Okay, now this is very important point. A. Start. Calculate. W1 equal to half into 1.8 into 7.5. Half into 1.8 into 7.5 is the area, into length is 1, density is 22 for dam. Tell the answer. It will come in kilonewton. Actually, kilonewton for 1 meter length. Answer fast. You know yesterday. What is the answer? This answer you know it. See, I took last time this one first. Now this one first. How much answer? Yesterday I done it. This W1. First. This W1 value. Yesterday we have done it. Yesterday's triangle part. Why I am giving so? Because easy approach. This is how you do in retaining wall. 148.5. And W2 is 2.5 into 7.5 is the area into 22. Tell W2 in kilonewton fast. Tell W2 in kilonewton. W2 in kilonewton. Don't give wrong values. W2. You are delaying a lot. This delay is costing time. 412.5. Okay. 412.5 kilonewton. Okay. Now, no other load. See, if it is a cantilever retaining wall, then base slab weight will be there, W3, and this much soil you have to take, W4. which is resting on the base slab. That's okay. This area into 25 concrete, this is soil weight, base into height, that you calculate, account it. So in RCC class I have done it. So our purpose is what? Principle. Okay, now, after completing all vertical load, calculate, therefore, resultant vertical load. Vertical load. I will call WR. W resultant vertical is W1 plus W2. Resultant vertical load, WR. How much answer? Calculate those two, add those two. First, add those two. You get resultant vertical load. Fast. Add these two, get resultant vertical load in kilonewton. You should 561 kilonewton. Okay, now what you want is to locate line of action of resultant vertical load along AB. Okay, see, for that one, before that, see, 1 minute, along AB. But before that, get WL, that is resultant lateral load due to water pressure. See, now this maximum pressure, calculate here, equal to 9.81 into 7.5. Tell the answer. Kilonewton per meter square will come. This is 9.81 into 7.5. What is the pressure? This all you have to fill up. This pressure here, maximum pressure. 9.81 is the density of water into resultant load. Pressure 73.58. Now, WL equal to, I told you, the lateral load equal to area of pressure diagram. You write here, area of pressure diagram. All are given in the red color earlier. Half into 7.5 into how much? 73.58. Tell this also in kilonewton. It's all kilonewton for 1 meter length. How much answer? Or one formula is there. Density into height square by 2. That also will do. Or moment right formula. Density into height cube by 6. People who know little more, they will directly use the moment term. How much this one? This one, WL. This also yesterday we have done. 275.906. 906 kilonewton. Okay, now to locate line of action of resultant, let resultant vertical load, see resultant vertical load, that is your WR, cut AB at X, comma, at X bar from A. That is this way. See, the result, this is A point, this is B point, total length is 4.3 meter. We don't know, randomly take. This is the W resultant equal to how much? 561 kilonewton. Let it cut at X bar from here. Okay, now apply Varignone's theorem. Apply Varignone's theorem. You write the theorem. Algebraic sum of moments of the entire force system. You should write. See, algebraic sum of moments of the entire force system, including WLY, because WL, even though it is not a vertical load, it will create a moment. Including WL, about any point, about A equal to moment of resultant load WR about the same point, about A. See, those who want right here. algebraic sum of moment of the entire load system, given force system or existing load system about A equal to moment of resultant about A. Start. Take clockwise positive. You get, see, W1 is acting at this distance is 1.8 means 2 by 3 of 1.8 is 1.2 meter. W2 is acting through center, that is 2.5 by 2 equal to 1.25 meter. Start. Take moment. W1 into 1.2, positive. W1 into 1.2 plus W2 into, see, be careful, moment about this point, 1.8 plus 1.25. 1.8 plus 1.25. Still not over. Then WL, lateral force. WL into 2.5. Remember, these are clockwise, that is anti-clockwise. So minus sign required. Equal to resultant load WR into X bar. Now, WL is how much? WL is 275.906 kilonewton. W1 equal to 148.5. W2 is 412.5. WR is 561. Therefore, get the value of X bar. Answer. It will give you where resultant, what millimeter, meter. It will give you X bar. Fast answer, X bar. Correctly calculate, give me X bar. Accuracy for third decimal. Third decimal accuracy, give me X bar. Fast. Don't waste time. Third decimal accuracy, give X bar. Don't waste time. 148.5 into 1.2 plus 412.5 into 1.8 plus 1.25 minus 275.906 into 2.5. Answer divided by 561. Get me X bar. .3307 meter. Okay. As soon as you get X bar, little work is there. Right. Put the baseline. This one. This is A, this is B. This full is 4.3 meter. Mark center of gravity, base center. This is half of distance, 2.15 meter, 2.15 meter. Now, X bar you got 1.33 means resultant will come here. See, this is the resultant line will act here. This is your X bar, whatever you got there. Whatever you got there. We want this distance. That is called eccentricity. Therefore, calculate eccentricity. Eccentricity E. Answer. It is 2.15 minus X bar value. Answer. It will tell you eccentricity in meter. Habit by millimeter. Okay. How much eccentricity? 2.15 minus 1.3307. What is the eccentricity? It will tell you eccentricity. Now, little calculations are there. 2.15 minus what? X bar. Eccentricity. See, this full width is called B naught. I will call B naught. This B naught will become structural depth. I told you. Structural depth later. So when this way moment comes, this is structural depth. 0.8193 meter. Okay, now apply the check. See, for no tension, no tension earlier. Now not no tension. For no lifting. For no lifting, eccentricity E should not exceed B naught by 6. One middle third rule. Eccentricity should not exceed B naught by 6. So B naught is the maximum eccentricity allowed for no lifting. Okay, start. Equal to B0 by 6 is, so equal to 4.3 divided by 6. What is the answer? Eccentricity should not exceed 1/6 of the B0. So B0 by 6, answer 4.3 by 6. 4.3 by 6 is the maximum limit for eccentricity. Directly it will give eccentricity for you. Point, how much? 47167. Okay. Now compare. Therefore, your eccentricity actual, which is 0.8193 meter, exceeds your B0 by 6, that is equal to 0.7167. This is the maximum limit. Therefore, tell me, your eccentricity exceeds here. Therefore, okay or not okay? Tell me, okay or not okay? This you know yesterday, because yesterday you found out that lifting was there. Is it okay or not okay? Okay or not okay? Tell me. Eccentricity is going beyond that. No, not okay. Not okay. Therefore, make a note. If it is a practical case, lifting is to be prevented. Only alternative is increase the base width of the dam. Clear now? Increase the base width. Now clear or not? Increase the base width. So here you won't do it. Why? This is analysis. Increase the base width. Clear? You should write. Or retaining wall. Increase the width of base slab. Clear? Okay. Now, however, right here. So therefore, here lifting is there. So gone case. But still, just to academically continue, what you do is, I will do here now, just to continue further, to check the answer. Therefore, now next what to do is, make a note. Actually, this base width is not sufficient. It should be increased. So practically, further continuation is not there. Go back and try around, not 4.3 meter, maybe around 5 meter. Okay, try. But here, because we are in strength of materials, find pressure. How? See, maximum pressure at ends equal to our B by A plus or minus M by Z is our usual formula. Okay, now your P is not what? Vertical load, that is WR. Area equal to width B, B0 into length 1 plus or minus. M is WR into E. See, WR into E. Divided by Z is, when you take, this is the axis, this is the structural depth. BD square by 6, it is 1 into B0 square by 6. Or you can tell pressure at ends equal to WR divided by B common into 1 plus or minus 6E by B0. If you remember, this is the formula used in retaining wall. When you do RCC retaining wall, the teacher in charge, he will not tell all these things. He will take the formula, pressure at extreme ends are given by WR by B0, or B he will call there, into 1 plus or minus 6E by B0. Remember it, tell me. Remember it in RCC, design drawing paper. Someone told that way. WR by B into bracket 1 plus or minus 6 times E divided by B0 or B. That's what they will tell. Clear or not? This is how in RCC you go do one thing. You open your RCC notes of the college, long back retaining wall. 100% this formula is there. How it came, he won't bother. That's all not required for you. Some will tell, you won't understand. Okay, now start. Now, pressure. Now, Use positive sign where pressure is maximum. Use negative where pressure is minimum. Tell me. Resultant load falls which side? See, your resultant load comes here. Therefore, A and B. Where resultant load? Resultant load is here. Therefore, tell me, maximum pressure will be at A or B. When the load is this side, see, this is the load. Maximum pressure will be at A or B. First, common sense. Maximum pressure is at A or B. Think a little and tell me. Resultant load is here. You are leaning this way. A. So A, maximum pressure. B, minimum pressure. Okay, start. Maximum pressure. Last time you are done by what? You are done by same thing, but some other formula. Equal to WR. Where is WR? 561 divided by 4.3 into 1 plus 6 into eccentricity is where is eccentricity? 8193 divided by 4.3. This will give maximum pressure which will be at A. Which will be at A. Answer. Tell the answer. Maximum pressure in kN per meter square. You should get the same answer as yesterday. Yesterday what you got? Same should come now. What answer you wrote yesterday? Ditto answer. First. Yesterday I given pressure for you. You got it. Why? Yesterday was simple example. See, this time there is no confusion of that small thing. Systematic approach, you can do it. And sometimes people go for Excel sheet for this one. Tell the answer. Maximum pressure. It will surely come positive. Means pressing. Tell the answer. How much? Maximum pressure. Answer. Maximum pressure. Fast. I am going to conclude now today. Today will be almost everything will be over. Hope nothing left out, but you should give answer fast. And then calculate minimum pressure. Minimum pressure will be at B. Formula is same formula, 5.561 divided by 4.3 into bracket 1 minus 6 into 0.8193 divided by 4.3. I am sure it will come negative. Why negative? It will come negative because we know that lifting is there. Negative should not come. 279.614. Until the minimum pressure will be negative. Actually should not come. That came because lifting is there. Anyway, we applied formula. First of all, you should not come here. You should increase the base width. Ensure that E does not exceed what? B naught by 6. Then this will come positive. This also will come positive. Answer. Say, leave it. Same as last time. Over. Sufficient. Leave it now. Better. Answer better. Same as last time. Okay. Now, make a note. So, this question, practically, no. You have to increase the base width. Second one. Maximum pressure that should not exceed SBC of soil. And whatever lateral load is there, that will try to cause sliding. So you should check for sliding, for a sliding force of WL equal to, where is it? Somewhere, I forgot, where is it? Somewhere there, WL equal to some kilonewton. Yes, 275.906 kilonewton. Now, tell me, fully clear? Fully clear means I will go to the next step. Don't waste time. Full clear, yes, minus 18.7. Okay, leave it now. Full clear? Because I am going to conclude now. That is the foundation part. Very important now, practical knowledge. RCC told, still I will conclude. I will close this. Today it will be over. This chapter will be over. Okay, clear. Now see. Now make the most important note. See. I will write partially red color. So those who want to get a good knowledge, study thoroughly from now onwards. What you have done earlier not required. Required means that is only for stability of dam or retaining wall. Okay, now, one small note you have tried. See. Okay. First time rubbing is sufficient. See. Consider footing for RC slab. Footing for RC slab. RC column. What RC slab? RC column. Remember, make a note. It can be isolated, or it can be combined footing, or can be raft. Whatever is no problem. If it is isolated footing, only one column load. If it is combined footing for two columns, two column load with moments. If it is raft footing, multiple column. But finally, we are replacing by single load. Okay, now, let footing dimension in plan be S1 by S2. S1 by S2. Remember, but one small problem comes. If I take S1 and S2, if you remember, there is a problem. What is the problem? When you go for RCC part, there column side also is required. This is earlier I told, earlier. But right here, in case of RCC, S term is used for column side, column dimension. Therefore, in our class, we will take footing dimension in plan as L1 by L2. Remember, in RCC, S1 by S2 is for column cross section. This is a footing, so I will take L1 by L2. Okay, now this is cancelled because now if it is a column compression tension, right here, if column cross section, say S1 by S2, our discussion is compressive stress or tensile stress. Compression you take positive, but for footing we have to consider pressure. Therefore, remember, if the footing slab presses the soil down, then from soil there will be upward pressure. You write here, this is footing pressing soil. This is upward pressure. See, this way. Upward pressure. This is good. This is equivalent to our strength of material compression. And if the footing slab get lifted here, this is upward, then from soil you read downward, prevent downward pressure, which is not possible because soil cannot prevent lifting. This is equivalent to our tension in strength of material. So, in case of footing, what? We always want upward pressure. That is, what we want is net pressure or pressure. Always we want positive. That's all. We always want positive, negative to be avoided. Okay, now further, lastly, for column, load is this way. Therefore, this is the cross section. See here. That is, cross section is S1 by S2. Whereas For footing, load is like this only. Therefore, this is the cross section. Or for footing, cross section is in plan. L1, L2. Okay. Last note. You all write this one. Last note. Footing dimension in plan is like this. A, B, C, D I will call. A, B, C, D. This is L1, this is L2. Therefore, area of cross-sectional area A equal to L1 by L2. This everybody knows. Okay, now, the most important, which actually I told earlier repeatedly. See, now, I will put 3D sketch here. This is the sketch. I will put A, B, C, D. And again I will put here A, B, C, D. Again I will write A, B, C, D. Not practicing English. A, B, C, D. Once again I will write A, B, C, D. Good A, B, C, alphabet practice. A, B, C, D. Consider, see, moment like this or moment like this. This is L1, this is L2. L1. And this is L1, L2. Anywhere, L1, L2. Okay. Moment like this or moment like this. M like this, M like this. This M is, one thing forgotten here, axis you require. I'll put the axis here. Red color required, axis. Yes, right time when the requirement, yes, correct, got it. You make a note here. This is your axis 2, 2. This is the axis 1, 1. Now, if moment is like this or like this, it is about this axis. 2, 2 axis. So this M, here, I'll write a note here. See, here M is M about 2, 2. See, this way or this way is about this axis 2, 2. Therefore, we will call it M2. For this M2, structural depth. Tell the answer. Structural depth. Answer. L1 or L2. For the axis 2, 2. Thousands times told. For axis 2, 2. Structural depth. S1 or S2. Structural depth first. For axis 2, 2. Structural depth. S1 or S2. For axis 2, 2. Structural depth. What happened? For this M, this is M about 2, 2 axis. Structural depth, which one? This much time to decide. When the moment is this way, that you call M2. See why? M about this axis. Structural depth first. Sorry, L1 or L2? Oh, L1. Structural depth is L1. Therefore, in the term Z, BD square by 6, B equal to L2 and D equal to L1. L1 to be squared. Or lastly, I will tell you crude method. Okay, 1 minute. If this way moment, then this side negative sign, this side positive sign. See, this will press this side. If for this moment, this is negative side, this is positive side. Now, this is your axis 1, 1. This is the axis 1, 1. Here, one moment can be like this or moment can be like this. This is M, this is M. For this M, tell the structural depth first. Structural depth for this M, how much? For this M, about this axis. Structural depth, how much? S1, L1 or L2. Structural depth for this M. Structural depth this way, L2. Structural depth is L2. Therefore, in the term Z equal to BD square by 6, your B is L1, D equal to L2. L2 to be squared, and if it is this way, this we will call M2. This side is compression, positive. Why? Pressing the soil. This is negative, this side. For this way, this is plus plus. This is negative. Now, last I will give crude method for you, those who find difficulty. See, you write, now I will not explain. See, I will tell crude method. Front-wise, lengthwise, what you are seeing is L1. Width-wise, what you are seeing is L2. Lengthwise axis 1, 1. Width-wise axis 2, 2. This moment is about this axis, that is 2, 2. When moment is this way, how your moment goes, that is structural depth. So for this moment, that side plus, this side minus. See, that side pressing plus, this side lifting minus. So squaring is this side. For this moment, axis here, 1, 1. Okay. For this moment or this moment, this side plus, that side minus. This moment, this side plus, this side minus. And for this moment, squaring is for what? See, if moment is this way, how your hand is going, that is to be squared. This I told in RCC, told in strength of materials, telling today last. In future, I will not tell. Tell me. Full clear means I will go to final table answer. Full clear. Okay. Now, the most important, see, final verdict. And one more thing. Suppose it is uniaxial, right here. Then nothing to worry. Use the same formula. One of the moment is 0. That's all. One of moment is 0. If it is uniaxial. Okay. Now, last part. Now I am putting plan. Consider plan. Plan. Remember, plan of the footing slab. That is actually structural cross-section. The plan itself is structural cross-section. See. Once for all settlement. Which is bigger, which is smaller, never bother. Lengthwise side is L1. Widthwise side is L2. Our symbol. Somewhere here later in RCC, S1, S2 will come. That you require to get L1, L2. Remember, to get L1, L2, you have to equate the projection. So equal. Here not required. Because here you are not bothered about column. Okay, now. Lengthwise axis 1, 1. Widthwise axis 2, 2. Now, this moment is about 2, 2. This is your M2. M2. It can be like this, or see, it can be like this, or it can be like this. We don't know. Anything is possible. Only one of them. This is M2. Now, why about 2, 2? Now next. This is your M1. It can be like this, or it can be like this. This is your M1. Only one arrow mark. Start. A, B, C, D, 4 corner. A, B, C, D, corner. See now. Pressure at any corner, that is pressure P, pressure at any corner. Remember, if it is RCC, you have two terms called, one is called gross pressure, one is called net pressure, that you study in RCC. Here only one formula, equal to plus compression. See, compression positive means what? Sign is compression on soil positive. Soil positive, that is positive means upward reaction. Upward. Negative means lifting. Lifting. Okay, start. It is plus P by A. When you want gross pressure in RCC, you write 1.1 P by A. That is because of self weight. Okay. P by A plus or minus M1 by Z1 plus or minus M2 by Z2. A is the area L1 by L2, or you can write L2 by L1, whatever you want. Z1, be careful, only once I will tell. Z1 comes for M1. Oh, hand is moving this way. When hand is moving this way, it is about this axis. Structural depth is that side. How hand moves? Hand moves along L2. So for this one, structural depth is L2. For this M1, structural depth is L2. Therefore, Z equal to, and structural breadth equal to L1. L1 into L2 square by 6. L2, be careful. And over. Then Z2. For Z2, Z2 comes along with the M2. M2. For M2, my hand is moving like this. Either this way or this way, length. So structural depth. Someone will ask, what is the structural depth? Hey, keep quiet. Don't answer. Talk with me. For M, see for each one, for your M2, structural depth is L1. Don't by heart suffix 1, 2. See, for M1, sorry, for which one? This is M2. For M2, structural depth is L1. Structural breadth is L2. So Z2 equal to, or see here, when you want M2, see, M2, hand is moving this way. L1 to be squared. L2 into L1 square by 6. Square by 6. Tell me, full clear or not? Fast. Full clear, fast, fast. Full clear. Okay, now, after all this one, lastly, sign to be decided. See here. First decide. Plan only input. Plan. Everything I am telling, nothing I am leaving. If this is the moment, this is the axis. Or crude method, if the moment this way, which side arrow is going is plus, which side tail is there minus. See, for this moment, these two plus, these two minus. For this moment, these two minus, these two plus. For this moment, these two plus, these two minus. For this moment, these two plus, these two minus. This also crystal clear. Tell me. This also crystal clear. Okay. Now, what I will do is, I will first take an example. Some few examples I will take, so that to make completely clear on me. Maybe I may read one more class. Okay. Because I should take the case of multiple column, or I will take one case of two loads, so that let us be completely perfect in center of material. See, example 1. Example 1. See, right. Once upon a time, there was a footing of lengthwise dimension 4 meter and widthwise dimension 3 meter. There, as shown, see this way, there is a load acting there. Here, I'll put a load here. Anywhere I can put the load here. There's a load perpendicular here to this one. See, this is the footing slab. A load of 2024 2000 kilonewton, which is at distances of this, this distance is 4 meter is there. 4 meter means, okay. Now 2 meter, middle third I want now. Out of scale, this is 2 meter. This is 1.6 meter, and this distance along this way is 1.15 meter. This is acting. This is the corner ABCD. Never bother lifting is there or not there. As per the formula, find the pressure at the 4 corners. Find pressure at 4 corners. Okay, over. Now start. First, this load. First step, put the plan. This is the axis. 1, 1, 2, 2 are not required. See, load is acting here. P. I will call the load P. This distance is 1.6 meter. This distance is 1.15 meter. So this I will call axis 1, 1. This I will call axis 2, 2. Now, we want what is this distance and this distance. See, this is 3 meter. So, half of is 1.5 meter, 1.5 meter. Half of this way is 2 meter and 2 meter. Start. Tell me, answer. This distance. This is a case of eccentric load. This is a case of, right here, a case of eccentric load. Or you can remember eccentric column. You can remember that way. Eccentric column transferring only axial load, no BM. Tomorrow I will tell you eccentric with BM. I will make everything. I think one more class required. Okay, we will study it. Tell the answer. Don't waste time. I want these distances as red color I want. From 2, subtract 1.6. This is 0.4 meter. From 1.5, subtract 1.15. This is 0.35 meter. Okay. Therefore, now this will become equal to, see, you can this can be replaced by load acting here, you bring it here. Load acting through CG. And then, see, this is your 2, 2 axis. This is 1, 1 axis. If I hold 2, 2 here, this load is this way, will create a moment like this of P into 0.4. A moment like this will come. That is moment about axis 2 equal to P into how much? 0.4. P is 2000 kilonewton. So this moment equal to 80, how much is one? This is 2 into 0.4 is 800 kilonewton meter. And this load, this over, about this axis, distance is 0.35. It will create a moment like this way. This moment is your M1. M1 equal to P into 0.35. 0.35 equal to 2000 into 0.35 equal to 700 kilonewton meter. Very heavy moment. This is a dangerous column. Okay, over. Now, full clear? Tell me. Is it fully clear? Fast. Is it fully clear? No, it was a present, at present you are not typed. Everything fully clear? Because now we are going to go to pressure calculation. Fast, fast. Full clear or not? No, no reply came. I get doubt whether audible or not audible. It was the previous yes. Long back yes. And right now no comment. You should tell so far full clear. We don't waste time. Just one yes your time. Otherwise I get doubt. Any audio problem is there? Okay, thank you. Now, therefore, our next step sketch will be, now it has come to no S1, see, little out of scale, okay. This length is, I won't write S1, S2, how much? 4 meter. This length is 3 meter. 3 meters. I won't write axis also now, see. I won't write axis also now. There is a load here, P. Now, P equal to, I'll put here now. Okay, there is a load P here equal to 2000 kilonewton. And there is a moment here, which is, this is the axis 2, 2. This is the axis 1, 1. This is M about 2 equal to 800 kilonewton meter. There's a moment like this here. That is moment about this axis. 1, M1 equal to 700 kilonewton meter. P is 2000 kilonewton. The corners are A, B, C, D. Therefore, start pressure calculation. This time, next time not writing. Pressure at any corner P equal to plus P by A. Now I am not having sign convention. Plus or minus M1 by Z1 plus or minus M2 by Z2. Okay, start. P is known, M1 is known, M2 is known, all of them are in. Now remember, in case of footing slab, footing units are kilonewton and meter, not Newton. Therefore, pressure will come in kilonewton per meter square. Okay, start. Area equal to, you can write either 4 into 3 or 3 into 4 equal to 12 meter square over. Z about 1 axis is here. See, this is 1 axis. Z about 1 axis. For this axis, squaring is 3 meter. Square, see, for this axis or 1 meter. For M1 squaring is 3 meter equal to 4 into 3 square by 6. It will come in meter cube. Tell the answer. 4 into 3 square by 6. Answer. 4 into 3 square by 6. Answer. L1, L2 not required. No L1, L2. 4 into 3 square by 6. Next time I am not doing this one. 4 into 3 square by 6. Next further example, when this sketch comes, I am stopping. Answer. 4 into 3 square by 6. How much? 6 meter cube. And Z2, see this Z1 is for M1, see, for M1. Z2 is for M2, this is to be squared. 3 into 4 square by 6. 4 square is 8 meter cube. Therefore, pressure at any corner equal to plus 2000 by 12 plus or minus M1. Where is M1? 700 divided by 6 plus or minus M2 800 divided by 8 or equal to, tell me, 2000 by 12. What is the answer? 2000 by 12. Answer. The second decimal sufficient. 2000 by 12, second decimal. 2000 by 12, second decimal. Second decimal is sufficient. 8. Hale answer. 2000 by 12. Ittottu beka to give 2000 by 12. See, I am asking 10 times now. Only to see. See, 160 plus 166.67 plus or minus 700 by 6. ನಾನೇ ಮಾಡ್ತೀವಿ ಬಿಡಿ, ನೀವು ಮಾಡೋದು ಲೇಟ್ ಆಗುತ್ತೆ. 700 by 6. 6 is 116.67 plus or minus 80. Now, correctly, pressure at A, pressure at B, pressure at C, pressure at D. Whatever you do, first term. P by, I have not done P by A. 166.67, 166.67, 166.67, 166.67. Then come to M1. M1 is this way. M1 will give plus at C and D. C and D plus. M1 will give minus at A and B. Now I will not explain. Term 116.67, 116.67, 116.67, 116.67. Come to M2. M2 is this way. B and C plus. A and D minus. 80, 80, 80, 80. Answer, 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 answer. Every answer in kilonewton per meter square, in kilonewton per meter square, in kilonewton per meter square. Then what you have to do is you can make a note. Our strength of materials part question is over. RCC, you have to consider the maximum pressure which should not exceed SPC of soil. At that time, for P by A, load you should take 10% more weight of footing. Okay, down. And the minimum pressure, least of all, surely this, which one? This one. The least value where, see, M1 will lift this edge, M2 will lift this edge. Together, corner A is the critical corner. There, pressure should not be negative. That is the check in RCC. Strength of materials part will stop here, get the pressure. Oh, this is 100. Ayo, okay. Calculator problem. 100. Okay, done. Not a big issue, but still 100, 100 and 100. Okay, over. Answer is not required. Leave it. Just tell me full clear or not. Just tell me, is it fully clear or not? Sufficient for me. Answer is not required. You tell clear, I will go to next question. You try it. You should tell clear. Very, very important next question. Clear. Okay. Now, most important example. What I will do is, see, but sometimes instead of giving eccentric one, axial can be given. That you try yourself only. Okay, see. Now, one homework for you. Homework. 2 meter and 3 meter. Axial load only I am giving. Axial load of 1000 kilonewton. Moment M1 like this of 120 kilonewton meter. Moment M2 like this of 75 kilonewton meter. Can you try this one now? Tell me. Can you try this and get the answer? This one. Can you try? This is corner A, corner B, corner C, corner D. I will give the answer for you at A, at B, at C, at D. Answer I will give. Now remember now, for this moment, these two plus, these two minus. For this moment, these two minus, these two plus. Be careful. Okay, I will give the answer. Load is not 1200. Load is 1200 kilonewton. Okay. Answer at A. What is the answer? Direct answer 200. Plus 277.5. Answer at B. Plus 197.5. Answer at C. Plus 122.5. Answer at D. Plus 202.5. You can try yourself only. Okay, now, no, leave it. Last question. Okay, we will close today. Why unnecessary next class? Today we will close. I will give homework for you. See, there is a footing here. See correctly, very important, there is a footing. This length is, I will take 4.5 meter. This I will take 4 meter. Now, unfortunately or fortunately, an eccentric column is there. This is a column. There is a load, see, there is a column here. There is a column here. See, somewhere eccentrically. This column has got a load and also a moment this way, see, this way of 200 kilonewton meter and a moment this way of 150 kilonewton meter, and column load is 3000 kilonewton. And where is that column? From here to here is 2 meter, little eccentric. This is 2 meter here. 2 meter means 1.8 meter. Where is the column here? This is 2.25, 2.11 meter. 2.1 meter. Okay. This is the column. We want pressure. See what to do. Be very careful now. First remember, see, solution. Briefly I will give you work out. You should get the answer now. What you have to do is, see, this is the axis, this is the axis. Everything brings to CG a load P of how much? 3000 kilonewton. Now, see, this 3000 kN load is acting somewhere here. It will create a moment like this, a moment like this. But column has got one more moment that way. See, there is a column moment 200 here. So, this eccentric column, when you shift here, it will create a moment of that load into this eccentricity. It will create a moment like this. And column also has got a moment. So together it will add up. Your net M will become, I will tell the answer for you. You try it. Once you get it, I will close. Oh, very heavy. 450 plus another 200. It will be 650 kilonewton meter. Those who get the answer understood everything. Remember now, this column, one couple is there. That you have to shift here. Plus because of eccentricity, one more couple. And here see, when you do this way, the column will create moment like this. But the couple is this way. Be careful. Here, 200 and eccentricity both are creating same. Add it. Here not that way. That couple is, given couple is this way. But load is acting that side. It will create that way. You should be careful. We don't know how it will come. That is 1.2. 0.2. Let load 3000 into 0.2 is 600. This will come net this way. That means I am sure that eccentricity will overtake. It will come 600 kilonewton meter. ಇಲ್ಲ ಇರಿ minus 150. It will come 450 kilonewton meter. Okay, this is your axis 2 2. This is axis 1 1. This is the final sketch. Final. Now you can go for happily pressure calculation. See, due to this way plus 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 plus, due to this way plus plus minus minus. Now enjoy it. Now almost 10 minutes there, no problem. Everything over, sufficient. Furthermore research you will not do. Multiple columns, all RCC I have done it. In combined putting, multiple column, raft putting, I have shown in RCC. This is not RCC class, but here, now you have to get this answer. You type got the answer and log out. Today, this chapter will end. You type there, you got the answer, final answer. This is the sketch for pressure calculation. You type got it, then log out. Others, I will wait. How many are there? Those who got it, just type. I will wait for another 5 minutes more. I will wait up to 9 o'clock, no problem. When everything is there, not there, then I will close the class. You type, we got the answer. Remember, column moment is there and the eccentric moment is there. It both may be same or different. Same means add it, different means find the difference. Okay. You tell me, got it or not. Suppose wrong, I am not closing the class, I will correct it. If requirement is there, I will correct it. 2.1, 4.5 is 2.15, 3000ಕ್ಕೆ 15 300 ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ? ಐ ಥಿಂಕ್ ಇಟ್ ಇಸ್ ಕರೆಕ್ಟ್ ಮೋಸ್ಟ್ ಪ್ರೋಬಬ್ಲಿ. Got it means thank you. So both the answer given correct? No. Both given by me, correct or not? Tell me. So that I don't have to check. Both the answer given by me are correct. Then okay, why should I check it? No. Both the moments I given. Correct means, if you tell correct means okay, then I won't check it. So later, someone should not comment in the YouTube that is a wrong answer. No, you tell me. Both the 650 lengthwise and 450. Both are correct means okay. I don't bother to check it. Because then if wrong, let them correct it. Comment first. Both are correct. If both are correct, okay. I will leave. I will see that comment box and see how many got the answer. You are not typing both are correct or not. If you type both are correct, I won't check it. I check ಮಾಡ್ತೀವಿ. ನೀವು ಟೈಪೇ ಮಾಡ್ತಾ ಇಲ್ಲ. ಕರೆಕ್ಟ್. ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್. You are correct. Okay. Thank you. The chapter will end here. Till 10 minutes time is there, no problem. Over. Those who are not getting I will wait for not 10 minutes. I will wait for 5 minutes and end the class. By that time, those who are present, today little more people are there. Type the answer. Yes, got it. At least let me be happy that people are getting the answer. Oh, thank you. Class will be still active for 5 minutes. Okay, I am closing now.